Hi everyone, welcome to this news episode of the Expert Talks Series. We are going to wait a few seconds and then we will kick off our day.
You see my screen?
Yes, Professor. Okay, so welcome to this new episode of the Expert Talk series of TRANS-SAHARA. Today we are honored to have with us an outstanding speaker, Dr. Ali Karnib. Professor Karnib is an associate professor of practice at the Lebanese American University in Beirut, in Lebanon. He holds a PhD in civil engineering from Artois University in France. He has published over 60 publications, which include scientific research and the United Nations technical reports. He is a member of the editorial board of Water Resources Management Journal and the International Water Utility Journal. His main research interests include the sustainable water resources management, assessment of the impact of climate change on water resources, water supply and sanitation, sustainable energy, and the water energy food ecosystem nexus. He developed the Q-Nexus model, a science-based WEFE Nexus model to assess the direct and indirect impacts of the interconnections between water, energy, food, and ecosystems. On the other hand, we are also honored to have with us today to lead the discussion Kwado Yoboa Asamoah is a researcher assistant at the chair of Urban Water System Engineering at the Technical University of Munich in Germany. He holds a Master of Science in Environmental Engineering from TUM and a Bachelor of Science in Civil Engineering from the Kwame Nkrumah University of Science and Technology in Kumasi, Ghana. He has worked as an environmental officer, the Environmental Protection Agency of Ghana, and his current field of research surrounds the water, energy, food ecosystem nexus approach and its urban applications. Thank you again for being here today with us. Just a couple of reminders before to leave the floor to Kwado. Please, the microphones and cameras are off. We have a Q&A button, so you can directly pose your questions there, or in any case, at the end of the webinar, we have located some time for your questions, so you can just raise your hand and we will grant access to the microphone. Thank you so much. To not further ado, I will leave the floor to Kwado. Thank you.
Thank you very much, Anna, for the introduction. I'd like to say a big thank you and a warm welcome as well to Dr. Karnib for joining us and going to share with us all his knowledge and experiences with modeling, especially in the water, energy, food ecosystems nexus. And thank you as well to everybody who's joined. Dr. Karnib, please go ahead.
Thank you, Anna. Thank you, Kwado, for the introduction. And I'm very happy to be with you today. And also, I'm happy that we have these participants to join us today. So let me start. First, the title of the talk would be about the modeling of the water, energy, food ecosystem nexus. So we will try in this presentation just to give some introduction to the WEFE nexus, and then how to get this concept or approach, to get this approach to be useful in the decision-making or policy-making. At the end of the day, all the modeling that we do, all the models that we create, they should be useful for something. So in this way, in the WEFE nexus, the usefulness of a model is for policy-making. Just a quick introduction of the WEFE nexus. So we know that working in a silo way, it's not actually feasible anymore due to many reasons. So let me just start by saying why we are looking for a WEFE nexus. So the main definition, maybe sometimes, by the way, the definition of the WEFE nexus, there is no official, let's say, general definition that everybody uses. Still now, I mean, now the definition of the WEFE nexus could be in different ways. However, and I see that this definition could be actually powerful or efficacious or efficient definition like saying that WEFE Nexus provides a holistic and integrated approach. So we have to keep this integrated approach to the WEFE Nexus and a holistic approach. At the same time, the WEFE Nexus actually try to get these interconnections between sectors by defining or highlighting the synergies that exists and the trade-offs. So the purpose of all these analyses should be fit to achieve greater policy coherence. Of course, coherence between all the sectors. So maybe this is one of the definitions that could be very good to mention, actually. Okay, so if you want to look like a macro view, when we start thinking about the Nexus, of course, the IWRM is the base of the Nexus. IWRM, the Integrated Water Resources Management, it was the basis of the Nexus thinking because IWRM took water and looked into the integration of other sectors within the water sector. However, we'll see later on in the presentation what are the basic difference between IWRM approach, which is an old approach. Maybe we can say it's older than 1992, but officially we can say that in 1992 they provide like a definition or a very clear concept of what the IWM means. And starting from that, we have a focal milestone, which is in 2011, when the Nexus conference at Bonn conference in 2011 that was dedicated only for the Nexus approach. And starting from that, it was emerged a lot. Of course, 2015, the UN SDGs also confirms that Nexus is very important to achieve all the SDGs, not only the SDGs that are related to the four sectors. I mean, water, energy, food, and ecosystems. So, and now we can, if we want to look now into the publication and literature, we can find actually thousands of papers and articles talking about the Nexus. And it's emerged a lot, many applications, and so on. Okay, very important question, and from my opinion, it's very important to understand the difference between IWRM and Nexus. Because many, frankly speaking, I read many studies or papers that are talking about the Nexus in the title. They mentioned this is a Nexus, let's say, study or Nexus research, whatever. But if you look into details of the study, you will find that it's still IWRM. So, yes, you might find a Nexus like title, but deeply inside, if you look, it's not Nexus, it's IWRM. So there is really misunderstanding or we are not able, some scholars are not able really to differentiate when they do a study between IWRM and the Nexus approach. Let me explain that to you clearly. When we say IWRM, actually, we know that water is the center, and we look into the effects from water to food, from water to energy, from water to other sectors, whatever the sector. So, but still water is the context. In the IWRM, we'll never look into the energy to food. No way in a study of IWRM will look to energy to food, because IWRM is focused on water. Whatever you take any interaction between sectors, water is still in the interaction. However, if we go to the Nexus approach, as shown here, the interaction is not actually from one sector to another. So water is here, is one among other sectors. And the interaction is for the four sectors, or it depends how many sectors we are taking. So all these sectors are interact to each other. It's very important to understand this feature, because in the modeling next, when I show you the models, you will find how in modeling the Nexus models could take into consideration all these interactions from direct effects into indirect effects. And here you have to learn the indirect effects of the Nexus, because the IWM are not able to take this into consideration, whatever is the method that you are using in IWM. Since they don't take into consideration these interconnections between all the sectors together, aside from water, IWM could not actually calculate or evaluate these indirect effects. And I will show you directly in the modeling here next how this could be feasible in the Nexus models. Of course, I want to say that challenge is big. Why we are taking the Nexus? Because we know that if we want to look to the population growth, into the increase in water demand, increase in food demand and energy demand, also taking into consideration the impact of climate change, sometimes drought, sometimes variation in precipitation, and changing all the food production, and so on. So all these challenges should push us to talk and find optimal solution that take into consideration the Nexus assessment to map all these impacts between the sectors. Fine. So I will skip directly on these information, these slides, because I know that it's a general information that most of you know that how much we need water for food, or where we can see that water is needed for food. Of course, we have lots of uses or demand from food sectors towards water. Of course, we need it for cooking, for irrigation, for production, and so on. The same thing, water for energy, we need it for extraction of fossil fuel, production of electricity, and using it as a cooling, for thermal power generation, of course, hydropower, biomass production, if we're taking this as option for energy production, and so on. Even for the renewable energy, I mean, for solar energy, we might need also water to wash the solar panels. Energy for water also, it's obvious, many options, like water extraction. You need energy, water treatment, desalination, of course, and the regions that they are scarce in water, they need lots of desalination activities, and this consumes a lot of energy. And of course, distribution, transfer, treatment, and so on. Energy for water, so this is some numbers. We'll talk about these numbers later on, how much kilowatt hour is needed for 1 meter cube of water produced, either in the surface water or groundwater. So of course, the energy consumption increase based on the type of water used or produced. Energy for food also, it's obvious, from starting from seeds inputs to the production, transport, storage, processing, transport, again, I think, then marketing and end user. So all these value chain is consuming energy a lot. Fine. So after this quick introduction, we have to make sure that we understand that any food trade or any product trade, there's embedded water and energy, and this is what we call the virtual water or embedded water and energy. And this is important for policymaking, actually, to know when they are importing a number of products, particularly for food, because food is or agricultural products are the main consumer of water. So when they importing or exporting any products, they know what actually they are importing or exporting this virtual water with it. And this could be done actually, again, by a Nexus assessment. Maybe a rapid question just to wrap up this section. If we want to ask you, I want to ask you, of course, if you look to this figure here, you might see the direct effect of this figure is you are seeing like a water losses from a transmission pipe. This is a transmission water pipe, and we see here that there is a losses of water. And of course, here, obvious, it's a food waste. So looking to these two figures, it's very, very obvious. You can say that here we have water losses and here we have food waste or food losses. So this is the direct effect that I talked to you, or the direct impact that you can think about it. However, if you want to think nexus, you have to think more deeply on that. And you can, in this figure, you should say it's not only water loss, but also it's energy loss. Why it's energy loss? Because the energy used to produce this water is lost with the water. Similarly here, you might say it's a food waste, but it's at the same time, it's a water loss or water waste and energy loss. Because the types of the quantity of energy used to produce this food and the water used to produce it is lost with this food. So this is an excess perspective. Now, how to quantify? So here we enter into the quantification. Okay, we know that there is energy loss and water loss in the food waste. We know that there is energy loss in the water losses or water waste. However, the question mark is how to quantify. And then we will use the modeling or the Nexus modeling to quantify all these losses. Actually, this slide, maybe it's a very good one to make the difference between IWRM once for all, to show you in practice how the difference is between IWRM and the Nexus approach. Looking to this slide, here, if, for example, the policymaker needs to make additional food. Okay, so they want for food security, for somehow they asked as a policymakers to produce additional agriculture products in the country. So obviously this additional quantities, it will need additional water to produce and of course additional energy to produce. So at this level, we are talking about the direct effects on water and energy for this additional food. So at this level, we can see that the IWRM can actually assess or make assessment or evaluate these additional effects. However, if you want to look into a holistic approach, this additional water needed here, it needs also additional energy, hidden or indirectly. Similarly, for energy, it might need also additional water. So all these are hidden. Now, if we continue the assessment, we might say that there is a multi-effects, indirect effects that exists. And if we want to compute exactly what is going on in terms of Nexus assessment, we have to calculate all these quantities and to answer that this is the total water input that is needed, not only this one. Okay, so all these are the indirect effects that could be calculated using an Nexus model. However, the IWRM model, it cannot actually go beyond this level. Okay. So the situation is complex, as you can see, and we need to do it by models. I will skip this because here, maybe this is an Nexus, how to think about a Nexus solution. Or I will go rapidly on that. So when we categorize a solution as a Nexus solution, of course, we have different types of Nexus solutions that could be labeled as a Nexus. We might have technical solution, natural-based solution, or even governance. So, for example, if I want to take technical, the wastewater treatment plant that take also into consideration transforming the sludge into energy by anaerobic digestion. This is a typical Nexus solution that can give benefits. Firstly, for water sector because it treats the water, and it have additional, it can be used additionally in the water sector. Second, it's a benefit for the environment because it released the pollution that could be released is not released, and this is a benefit for the environment. It's a benefit for energy because it produces energy from the sludge. And finally, it's a benefit for food, for agriculture, because we can use this water, treated water, as additional water for agriculture. So you can see this type of solution could be labeled as win-win for 4 sectors. So we can say that these are a four-win solution. So it's a nexus synergies between all these sectors. So in this way, we can actually look into the solutions and label it as a nexus. And the nexus assessment later on, it can provide you more detailed analysis to find all these impacts, not only subjectively, as I mentioned now. Now I directly, subjectively, I can decide or say that this solution can give benefits for all sectors. However, how much water is used, how much energy produced, and so on, all this could be assessed later on. Okay, many other solutions. Let me go to the next content or part, which is the qualitative analysis, because I start for the Nexus solutions, I start a little bit about the qualitative analysis. Qualitative analysis, or we can say it as a context analysis, it's a pre-phase of the quantitative. So we can, if we want to make analysis or assessment of the nexus, so if I want to say this is the nexus, I have to start with the qualitative or context, and then go to the quantitative, which is much more detailed in terms of quantities. So phase 1 and 2. So we can start with this type of chronology into the assessment. And the quantitative or context analysis, it's very easy analysis. You have to go to experts, maybe stakeholders. You bring lots of stakeholders into your an assessment. Of course, you can do it alone. However, it's better to do it with multi-experts and multi-stakeholders from different perspectives to bring all the perspectives from water, energy, food ecosystem, and so on, and to organize this assessment into like this matrix that it shows here. So you can map in each cell of this matrix what are the impacts of water in the energy sector. So you can put here some context impacts. Of course, here you don't have numbers. Of course, just only you put the impacts in terms of like what are these impacts. You provide, you identify the impacts, and then taking into consideration, as I said, all the perspectives from stakeholders. So finally, at the end of this analysis, you might have this matrix fill in, and when you look into the problem, you can directly show the interconnection between the sectors in this matrix as shown in each cell of this matrix as a context analysis. Now we might move to the second phase or second part, which is the quantitative assessment. So since we have the context analysis matrix and we know which sector we should focus on more quantitatively analysis to take decision or to inform policy making, so we have to move to the nexus assessment. To make a nexus assessment quantitatively in the nexus perspective, of course, we might think about the first question that comes to our head: why we want to put all these efforts in the quantitative analysis? What would be the benefit of these efforts and collecting data? Because, you know, quantitatively, any assessment that you want to take quantitatively, you need data, and this data sometimes take maybe financial resources and human resources to collect all these data and put it into the model, and this is a cost. Yani, you have to pay cost for these data to be collected. So what are the benefits of collecting all these data, put it into the model, and then take the results? The main input, the main actually benefit of making this analysis is to providing or informing the policy making, and how it could be done by taking, for example, different scenarios in the future for our maybe strategic plans or for any, let's say, strategy, either for water, for energy, for food, what you want to plan in the future, in the next, in the near future or medium term future, or maybe even in the long-term future. And here also these scenarios, you put your planning, what you want to choose. You want to increase demand, for example. You want to increase energy demand and food demand. Those might be a potential scenarios in the model. So if you increase all these demands in the future, of course, based on population growth, and maybe based on also like increasing of food production or energy production and so on, then also other types of scenarios that you can make test is, for example, go to reuse options, produce energy from renewables, upgrade your agriculture technology by switching from surface irrigation towards sprinkler or even micro irrigation, technology change in the electricity production. All these technologies change could be also a scenarios for your model. So when you are planning in the future, you put all these scenarios in the model, and the model give you what would be the impacts on the 4 sectors, I mean, water, energy, food, and ecosystem. So this is the benefit. I don't know if you see clearly this benefit, because if you go to any option without making a scenario assessment, you might go for the wrong option and put a strategy wrongfully, or you might put a strategy on something, and at the end, when you arrive to this time of implementing, that you are not able to implement. Not because the option itself, but also because the other sectors, they could not fit or commit to achieve or to implement your strategy. So this is the importance or the benefit of making this assessment. Okay, so here I see I put in summary all these scenarios that could be done. By the way, when we put our scenarios in the model, we can take 1 by 1 or 2 by 2, or maybe we can make a combined scenario. We can take all together. So it's easy once you have the data, it's easy to simulate and see what are the impacts. Okay, so the cost is only to get the data, and then you can make lots of simulation very fast, very and you get the impacts easily. Fine. I will here. So the idea is clear. So before here, I skipped this this slide. It's a case study from Kuwait. We did an assessment, an overall assessment on the WEFE Nexus assessment as a national wise in Kuwait. It was a PhD actually study. So here I present to you what are the scenarios that we took into consideration for Kuwait, for example, because scenarios could differ from one assessment to another, from one context to another. It depends on the context of the countries or the case study taken into consideration. For example, in Kuwait, we took the reduction per capita of water consumption. They have a high rate water consumption per capita in the water supply system. We took a scenario for switching to more energy efficient desalination technology because they rely a lot on the desalination. Also, we take a scenario of irrigation efficiency and switching from oil to natural gas power generation as an electricity generation, and we took a combined scenario to see which one is the best. So obviously, all these scenarios are benefits, could generate a synergies or could generate a, let's say, a positive impacts. But the question is, if we produce or program or plan these scenarios towards the future, taking into consideration the population growth and the climate change, this would be a very critical situation that decision maker need some information to decide or to know about it. Okay. Of course, here to start the modeling process, to present to you how to create a model in the Nexus assessment. Firstly, I have to introduce that each type of each sector, like water, energy, food, and ecosystem, taking, for example, the energy production, we have different types of energy processing and production, starting from extraction of oil, for example, into processing, into power generation. So we have to know that there is different subsectors in each sector. Similarly, here we can see that, of course, we have to rely on this value of intensity here, and this value, as I said, it's a data value, and this is a main value to use in the simulation. Okay, when we create the model, it's very important parameters that we want to use. These parameters we called as intensities. What's the feature of this intensities? It gives you the relationship between one sector, the water, and the production of another sector's, the energy in this case. So if you are extracting, for example, a conventional natural gas, you might not use water. So the water intensity is 0 for 1 gigawatt hour of energy production. However, if you are extracting shale gas, the water quantity, it's very high in this case, and so on. So these intensities, actually, it's the basic component to start making simulation and making scenarios and see the effects, the interconnections between these sectors. We might talk in the discussion how actually to calibrate these values, because since these are inputs for the model, we have to find and calibrate these data before entering these into the model. Of course, this not only related to one sector towards the another, it's related to all the sectors, the interconnection between sectors. For example, here what we are seeing, the water towards energy, we might have some values of these intensity in different types of technologies or processing. Also, we might see, for example, all these are examples of how water is used in different technologies of the energy industry or energy production, and this gives you actually a large way to simulate technologies and options later on. But also we can look into from the other side. This is for renewable, still the same. From the other sides, how water is used. How energy is used in the water production, particularly in desalination. So we have some numbers. How many kilowatt hour is used to produce a 1 meter cube of, let's say, desalinated water based on different technologies, okay, of desalination. So you have all these intensities here. Even for the water extraction, we have also some numbers or some intensities. Here for the surface water, we might use 0.2 kilowatt hour per meter cube. For groundwater, it can up to 1.5 kilowatt hour per meter, and so on. So all these are the intensities, and you see the first from energy towards water, and here too from water towards energy, and so on. So you have to get all these data together. Now, how to use this data into the modeling, how to create a model. I will talk particularly on the model developed, the Q-Nexus model that we developed, which is based on the input-output theory. When you create any model, you have to start with a balance equation. So quantitative models are always based on a quantitative balance equation that you can develop later on to include lots of variables into it, and finally to get the model. So in the Q-Nexus model, the quantitative balance equation is very simple. We divided the total quantities in this, let's say, in a row direction for intersectoral use. This is for example, let me take an example of water. This is the water. If I'm calculating this row in water sector, this is the water used for other types of sectors like energy, food, ecosystem. So here we call it as an intersectoral use. Why we put this into one? Actually, this is the innovation when you took a model and you develop a model. You have to split your balance equation in a way that it would be useful for you at the end to make simulation and scenarios. Here we can change in this value or this context. You can change all the technologies that are consuming water. So in this way, you can actually map or calculate these impacts. since you have this into your model. So intersectoral use plus end use, all the water used in the demand side. If you make the summation of these two sectors, these two quantities, you will get the total use of the water, like as I mentioned in the water row. And you apply this for the other sectors. If you want to give you another perspective, so this is the matrix of the model, the quantitative matrix. So you have here intersectoral matrix. You have all the intersectoral use from water to energy, from water to food, from energy to water, from energy to energy, energy to food, and so on. This is the intersectoral matrix. Here you have the end use, the demand side. Also, the demand side is important because we can increase in the simulation later on. We have made as a variable, the demand side is useful because we can increase the demand side for the future due to population growth or any other reason. And the total use, the summation of both. And this methodology that you are seeing here is typically the input-output theory. That are the input-output theory is very known method, is used in particularly in economy to map the economic impacts, because from this input-output theory you can generate the GPA of a country, or all the gross production of a country, based on all these interconnection between economic sectors. So we can start developing the model step by step. So we know that our model is based on this type of balance. Now we will write the equations to get the balance more into variable equations. So we have the water balance equation here, and energy balance equation, food balance equation. We can add as much as you need sectors, of course. This is explained for 3 sectors here. So now we know this balanced equation is written by variables. Now, how to link variables together and to get the model? Okay, we have to rely into the intensity I showed you before. This intensity is the magic, let's say, variable that can transform all these equations, all these variables into a model. So using this intensity in the model, we can rewrite our equations in different way. I'm writing the equation now based on this variable. So I introduced the A here, in the equation. And based on that, I can continue in developing all the variables into matrix representation. And finally, I get this, let's say, matrix representation of the model. Still, you have here intersectoral intensities. You have here the end use and the total use. So to solve this complex equation, fortunately, we have the Leontief inverse, which is, I told you, this is the input-output theory. The Leontief inverse is a magic way to solve all these complex matrix equation. You cannot solve this equation manually because here you have variable, the total. Here you have another variable, and here you have another variable. So you have at least 3 variables in the equation. So it's not easy to solve it in a matrix way. The Leontief is the magic solution. And the Leontief solution is, this is the Leontief solution. The total equal I minus A. A is the technology here, mentioned here. And Y is the demand. So you can put this one I, the identity equation minus the intensities, inverse. Of course, all these calculation in a matrix calculation, it's not linear calculation. And finally, based on that, we can say that we solved the complex equation and transform it into a model. We can make simulation and change these variables into the model and get the results correctly. Here, if I want just to show you why the Nexus assessment using this theory, input-output, it's much more developed or accurate than the IWM methods. The Leontief equation, this Leontief coefficient used in the solution, you can see that in the Leontief, you are calculating the first step of Leontief. It calculates the direct effects, but also it can calculate all the indirect effects into the model. So the solution that we extract from this theory, it can include all the indirect effects of the sectors. It included in the as a final solution for the variable, or also you can split it in the model. You can, for example, you can ask the model, give me only the indirect effect, so you can get it from the model, okay? Or you can ask him, give me only the direct effect, and so on. So this is also a very important flexibility to know what are the indirect effects of your, let's say, your policy that you want to engage in, either increasing demand, changing technologies and the production of sectors, and so on. So that's it. So briefly, I could say that the QNexus is based on this technology evaluator or Nexus evaluator. Of course, there's other actually features in the model that we split this technology factor from being a subsectoral factor. We split it into an intensity factor to the whole sector and allocation of sectors within the Nexus assessment. This is another feature beyond the input-output theory that is developed in the QNexus. And this make the Nexus assessment light data requirements, because this intensity, which is for the whole sector, not only for subsectors, which is different from the input-output theory, is very important to facilitate data collection in the WEFE Nexus. Fine. So later on, we can use this model, this assessment, in very applications. Here I can provide some applications that we used the Nexus, this model into it. But I see that we are actually at 45 minutes. We have to keep 10 minutes for discussions and questions. I will go rapidly in this. As I mentioned, we use it in Kuwait assessment. We took several let's say, subsectors in the water, in the energy, in the food, and we make simulation. The simulation that I showed to you, I will go through rapidly. Also, it was used in the United States in the water basin in the Pacific Northwest in USA, and they have this basin that is actually using the water and producing energy here as hydroelectric dam, and they have agriculture sector. So they make the simulation. They use the QNexus to simulate all these, and they put some projections for the future. And they calculate the data, and they map also the data into these types of mapping to say what are the interconnections in terms of quantities between all the sectors in the basin. And we can say also, we can also map all these types of figures, and we can make optimization. By the way, I didn't mention the optimization. In the QNexus model that I showed you, since the variables are we can control the variables of all the aspects of sectors, so we can add an optimization equation into the model, and then we can ask the model to optimize, for example, the water resources along let's say different types of variation in the technology in the sectors, or variation in the demand, and so on. So we can also add an optimization equation just to, if you want to make an optimization assessment. Here in this study, they make an optimization assessment. And finally, I would say that another application was done in Egypt but this time at the farm level. So you see that from Kuwait study, it was at the national level. From Northwest here in United States was at the basin level, water basin. And finally here, this is another example on the farm level assessment to see what are the difference, what would be the difference or the impacts if we switching from surface irrigation in Egypt towards micro irrigation in terms of water use, energy use, and impact on the environment. So we did this study with FAO, and we use the model for that. So that's it for the application here. All these are data or results from the Egypt case study that we show the impacts of the scenarios where when we introduce the scenario of drip irrigation, what was the benefits of in terms of water use and energy use. So all these are calculated based on the Nexus assessment. So I think that's it for the assessment. I have to go to the QNexus model online to show you a little bit how to make this. Anna, can we go 5 minutes additional time?
I was going to tell you, yeah, so if the others agree, yes, we can take 10 minutes more. No worries.
Okay, I just want to show the QNexus model actually is online. You can go and open it. It's freely open. But recently we made, let me show you. Can you see the screen? Yeah. We developed a desktop model for the QNexus. The online and this desktop are similarly in terms of running. However, here you can see more features. We added additional features that we can import the data from a template. So we can put all our data in Excel instead of developing or introducing the data in the model directly. Maybe in an Excel, it's much more easier to get data from Excel and directly inject it into the model. So once we add for example, look into a model, into a data, we can upload the data here. Let me find an example of Excel that we have the data. Just 1 minute. So once you ask to upload the data, you can see all these are uploaded, of course, from the Excel file. So you have the water sector, you have groundwater, surface water desalination in the data. In the energy, you have solar, PV, wind, and natural gas. For the food, we have cereal and vegetables. And once you upload from the Excel file, you have all the data included in this. I mean, you don't need to put any data in the model directly. So all it in the Excel, you get it from the Excel, and it's already done in the tool. So you can start from there to make some scenarios. Like, for example, here you see there's baseline scenario, renewable transition, and water conservation built in the Excel file. So I could take any of these scenarios and put it as an active scenario and look into the data of this scenario. So I can see here the intensities that I told you and the allocation are important for as an entry data for the model. And this you can do it from water. Here you can change from water towards another sector, towards energy, and from water, for example, towards food. So you have to put all these data in the model. And finally, you can actually add also the end use that I mentioned as a variable also, and you can change here from water to food. You have to put all the enter. And finally, you get the results. In the results, you can take sector by sector and look into other sectors. And also you can take sector by sector and look it into as a whole, all sectors together. And you make calculation. And you can see, of course, here, I think the values are not entered yet. It's still this scenario is blank. Here what you get actually, once you take a scenario and you run the model, you get all the intersectoral use in the model plus the total use and the end use. So if you have different scenarios, you can compare. So we have here a feature to compare scenarios. You can take the baseline, for example, and compare scenario 1, and you see the comparison between the two sectors, the two scenarios. So this is how to start. Let me, for example, refresh how to start, for example, a new project. If I want to start a new project, I can start a new project, and here the new project is blank. So you can, for example, starting by adding here, down here, a sector. You choose a sector, for example, water. You make a description. You choose the unit, million cubic meter of water as a unit. And you can also choose an icon for your sector. You have multi icons. It depends on the sector. So it's an open tool, by the way. It's not for 3 sectors only. It could be used for 10 sectors. Whatever you are making simulation or impacts or intersectoral impacts, you can use this model for multi-sectoral. So that's why we keep icons for all types of sectors. So you are creating here the first sector. So you can, once you are creating the sector, you can add supply option within the sector. So as you can see here, we are within the water supply. We can add groundwater. Of course, the unit should be the same. And so you created the groundwater sector. So you back to sectors again, and you add energy sector, and use unit mega watt hour, for example, and you choose the energy icon. So you created another sector, energy. You can go into this and here apply for energy sector, which is the sub-sectors. For example, you can say electricity. Let me say that fossil fuel electricity. And then I choose the unit, megawatt hour. So you have also here created. Now you can, once you started, you put all your sectors here, you can start entering the data here, and you can start entering the intensities. You can see what are the subsectors that are using in your application. Since you have only fossil fuel, in this example, it shows only fossil fuel, so you don't have many others. Once you complete your baseline data entry, you can start making simulation as a scenario. So you can define scenario by new scenario. Here, you click new scenario, or you can clone the baseline. If you want to change something in the baseline, you don't need to enter all the data again. So you just clone the baseline, and you say this is a scenario 1, and you change only the data that you need in your baseline. So you have this scenario is created. You can go and make it active scenario and change the data of this scenario because it's cloned from the baseline scenario. Thank you. So I'm finished.
Thank you very much, Dr. Karnib, for the very interesting talk, and as well for your nice demonstration of the Q-Nexus model for us. I think we all have a pretty good understanding now of the basis to use Q-Nexus, and we can follow up and practice on our own. At this point, I would like to open the floor to questions. So questions from the audience. I can see that already Tawich, apologies if I mispronounce your name, has a question. And the question is, he has 2 questions actually, Yoshi. That on slide 2, Tawich wants to know why the human was not included as the center of the water, energy, food ecosystems nexus.
Yeah, I think it's a very very important question. The human part is hidden. It's not really obviously shown. It's hidden. Why? And I agree that if someone that asked this question, he or she wants to make it clear and as a shown. But in our assessment, it is hidden in the looking to sustainability. When we make the water, energy, food ecosystem assessment, our background, we are actually going towards a sustainability of resources, and we are taking also when let's say the human sides into the sustainability. However, yes, we can make it more shown in the Nexus assessment, like for example, including the human socio-economic well-being, or now we can add also the human health, and so on. So it's feasible. We can do it. And we might do it in the future. Yes, I agree with that. But it doesn't mean that we are not really thinking about a human being in this analysis. We can integrate it in different ways.
Thank you. And the next question also from Tawet, which is a short one, is if the Nexus is an open access platform software.
Yes, at a certain limit. Now you can go and register in the platform. The tool will provide you with the username and password. You can enter the username and password and go. You have access to the platform. It's a trial for 3 days, just to be familiarized with with the tool and so on. However, if you need more, if 3 days is not enough to make your calculation, you can send me an email and I can open it to you.
Thank you very much, Dr. Ali.
أهلا دكتور طلال, كيفك?
Fine, thank you. Thank you. Very important.
To
Very important lecture. Thank you very much.
Thank you, Dr. Talal. It's a pleasure to having you with us.
Thank you.
Great. Thank you. Then I also have a question. So as we get closer to 2030 and trying to see how far we can achieve the sustainable development goals, I can see that more and more the whole WEFE Nexus concept is being applied in a lot of projects that are coming up. For example, this Trans-Sahara project that we are working on. But my question is, what will be needed so that we will have a wider uptake of the WEFE Nexus modeling in terms of aiding decision making to be able to accelerate achieving the sustainable development goals? What are some of the challenges, in your opinion, that is facing this wider uptake of the models themselves, and not just so the approach is being used, but the models themselves seem to be lacking a wider uptake?
Yes, Kwado, thank you for the question. When we develop a model, we can, like UNEXUS, it's developed for to accommodate many, it's a generalized model that accommodates many studies. However, when you want to solve a certain particular cases, we might look into what are, of course, could be done by stakeholder, let's say, elicitation to look into what are really, how the WEFE Nexus assessment could be beneficial for this case particularly. For example, I take an example for Kuwait, for example. In the Kuwait, they have desalination, a huge depending on desalination. So desalination is a very important factor and should be included in the assessment. And this is general. When you go to a certain water basin or certain national assessment, you have to look into what are their really critical issues that they need to make Nexus assessment to get benefit or to get more information about the interconnections. So in the Sahara project, I presume that agriculture is a very important part, and maybe making agriculture more efficient by micro irrigation or other types of irrigation. This would be a very important part. Of course, agriculture means also fertilizers, and fertilizers is related to energy somehow. Agriculture also means energy depend, like if you switch from surface to micro irrigation or sprinkler, you might need additional energy to pump, and so on. So in the Sahara, you need agriculture is one of the major items. Also energy production, what types of energy, if they are relying on renewable energy production or fossil fuel, what type of fossil fuel, oil or gas, because both are different in terms of water use in the production system. So once you have all these, you can start making, developing the case study.
Thank you. Thank you very much. And I have one quick follow-up question on that. With the development of case studies, especially in the areas that we are working in Trans-Sahara, we often run into the issues of data scarcity, so that it makes it really difficult to be able to have then simulate different scenarios and be able to really test out the models, because there's really no data to be found. So what, in your opinion, is one way in which we can address this very major challenge?
Yeah, it's a very mega challenge, not only in the African countries, sometimes also in the Middle East, in the Arab countries, we have the same problem of data scarcity. We have to be smart in applying the model, because in the modeling, when you need, in the modeling here in the QNexus, for example, quantitative model, you need intensities of interconnections between sectors. These intensities could be global if you can take a value from, like, for United States, because in United States the intensity exists, in Europe the intensity exists, you can find it everywhere. However, if you took this intensity to apply it in another context, another country, you can work on this intensity and you see if it could be taken as it is or should be modified a little bit to be applicable in the country that you are making the assessment in. And of course, here when we do this exercise, we are borrowing data from other contexts to our context. And borrowing this data, it means that we are not 100% accurate. There is uncertainty in our assessment. However, we can see that this uncertainty, but we can look into this uncertainty and we'll look to the output of the model to see if this intensity could affect our outputs in terms of policy making. You know, we have to just make this balance between the accuracy of the data and the policy making that we want to inform based on the simulation. In my opinion, usually it cannot affect a lot the informing part of the model, because still the model be useful even if you have some uncertainty in the data.
Thank you very much. At this point, I don't know if there are any further questions from the other participants online. Please feel free to unmute yourself and ask your question to Dr. Karnib directly. Okay, then I'll just ask one final question then, so that we don't go too much over time. And it's that you have developed a more advanced version of the QNexus, where you have incorporated ecosystems as well. So I wanted to know if you could just give a brief summary of how you went about incorporating the ecosystems into the previously existing QNexus model, which had previously considered the water, energy, food, and how you went about this incorporation.
Yeah, thank you, Kwado, for the question. It's a complicated question, by the way, but I will simplify because we don't have time to explain a lot. Ecosystem part in the Nexus could be could be used, could be assessed as the outside the Nexus assessment. You can make WEFE Nexus assessment quantitatively and see the impact on the ecosystem outside the model. Okay, once you get the data from the WEFE Nexus, you can look into the ecosystem outside the model. This is one way of doing that, but also we can do it inside the model. So to explain how to do it, and that's inside the model, we have to look into the ecosystem as we have to find a suitable intensity of impact from water, increasing of, for example, wastewater, taking wastewater as an example, how the wastewater generation in the model could impact the ecosystem in intensity. So we have to find a suitable measurement unit to include ecosystem in the quantitative analysis. Like, for example, impact on degradation. You can, for example, put a certain indicator for ecosystem degradation based on the wastewater that are generated in the model. So linking together these, you can, in this way, you can include the ecosystem into the model. And in energy is easy because the energy sector with the ecosystem is the CO2 emission. So it's very easy. We have this already, and we have this connection already. So we know that this type of energy, let's say fuel, has a certain kilogram of CO2 emission based on the fuel consumption. It's easy to do it for energy. For food also, we have to look into this because food production has fertilizers, and fertilizers, it will harm the ecosystem somehow. We have to find this relationship.
Thank you. Thank you very much, Dr. Karnib, for the clarification. So at this point, I can't see any further questions. So I'd like to thank you once more, Dr. Karnib, for your time, and hand over to Anna.
Thank you so much, Kwade, and thank you so much, Ali Karnib. I will echo my colleague in saying that was an honor, and also your presentation was not just interesting, but for sure we will look even more in details what you explained, and as Daphne was saying at the beginning, for sure there will be more occasion to collaborate together in the future, and we are looking forward to it. So thank you so much again. And in any case, just a quick reminder, the recording will be available on our website and also on our YouTube channel. So whenever you want to rewatch it, or in any case, go through the presentation data and everything, it will be available in the next few days. Okay, so thank you so much, and see you to the next Expert Talk Series episode.
Thank you. Bye.
Bye-bye.